Assalamu alaikum students. Hope you are fine. Okay, so today we are going to talk about data representation. That's chapter number one of computer science. Okay, so why we need to learn this chapter? So that we should know that how we can represent the data so that the data is understandable for the computers because computer only understand one particular language that is binary. Okay, so whatever we input in the computer, it has to be converted into binary language. Okay, and when computer is going to produce any result, it should be represented in terms of denary because denary is a language or the number system which is understandable by the human. Okay, so two things are clear over here. That why we need to learn number system so that we can communicate in between human and the computer. Computer understands binary number system and human understand binary number system. Okay, so first we are going to look at one example that how we are supposed to convert from binary to binary. Okay, so this is chapter number one, data representation. First, we are going to learn how to convert from binary to binary. Example is there in front of you. We have taken one example double zero double one double zero double one. This is a binary number. Now, as you know, binary represents only two values, either 0 or 1. That's why we call it as binary. Bi means two and nary means numbers. Okay. So in order to represent binary number, we are going to take the power of 2. As I've told you, binary has only two numbers. So we are going to start from our right side 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, okay, and then 4, 5, 6 into the power 7. Why still 7? Because we need at least 8 bits to represent a binary number. So from 0 to 7, there are 8 digits which we are going to represent using power of 2. Okay. So now 2 to the power 0. Anything having power 0 becomes 1. 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 16. Okay, 32, 64, and 128. So we need at least 8 bits in order to represent binary number. Okay, now we are going to put this binary number under this value as it is double zero double one double zero double one. Okay, after writing all the values under it, we are only going to pick those values having one under it. For example, 32 having one, we will pick this number. 16 having one, we will pick this number. 2 having one, we will pick this number. 1 having one, we will pick this number. Zeros are going to be ignored. Okay. And the values which we have picked, we are going to add those values. 32 plus 16 plus 2 plus 1. So that is going to be 51. Okay. So, and you see, we have converted from binary to denary. Is that clear, everyone? Now, we are going to see another example. Okay. We will pick the example from the book. For example, we have we are 0 and all ones. Again, we are going to do the same thing. What we are going to do? We are going to write down the same values. 1, 2, 4, 8, 16, 32, 64, and 128. Okay, you can see all are the power of 2. 1, 2, 4, 8, 16, 32, 64, and 128. Now we are going to write down the exact values under it. Okay, I'm again going to show you. See, first value is 0 and rest are 1. The first value is 0, rest are 1. We are going to do the same thing. The first value is 0 plus star 1. Now we are going to pick only those values having 1 under it. So we are going to ignore this value. We will pick this one, this one, this one, this one, this one, this one, and this one. Okay. Now add these values. 64 plus 32 plus 16 plus 8 plus 4 plus 2 and plus 1. Okay. So this is going to be 64, 32, 16, 8, 4, 2, 1. 4 plus 2, 6. 6 and 6, 12. 12 plus 8 is 20. 20 plus 4 is 24. 24 plus 2 is 26. And 1, 27. Then 6 plus 2 is 8. 8 and 3, 11. 11 and 1, 12. So this is going to be 127. So 127 is your answer. I hope this example is clear as well. Okay. Now we are going to learn that how we are supposed to convert from denary to binary. Okay. For example, I'm going to pick a one denary value that is 72. Okay. Again, there are two methods of doing it. The first method is very similar as we have done in question number 1. Okay. For example, 1, 2, 4, 8, 16, 32, 64, and 128. Okay. Now, what is the rule? The rule is that out of all these numbers, we have to pick a number which is either equals to the number which is given, or it must be less than to the number which is given. Sorry, less than. Less than is this one. Less than the number which is given. Okay. We cannot choose any number greater than this number which is given. We cannot choose it. Okay. So now what we are going to do, we are going to check. This is 72 and this is 128. We are going to start from the left side. Okay. 128 is greater than 72. And I told you that we cannot choose any number which is greater than. So we are going to put 0 over here. Okay. Now we are going to check the second number, 64. If you can see, 72 is greater than 64. So 64 has become lesser. So we can choose a lesser value. So we are going to pick 64. Whatever the value you are going to pick, you are going to subtract that value from the number you are looking at. Okay. So 12 minus 4 is 8. Okay. And 6 minus 6 is 0. So now we are left with 8. Now we have to pick a value which is equals to 8 or less than 8. So when we have 32, it is greater than 8, so we cannot pick it. 16 is greater, we cannot pick it. 8 is equals to 8, so we can pick this value. Now 8 minus 8 is 0, so rest of the values will be 0. So my result is 0, 1, 0, 0, 1, 0. So this is my answer. And this is method 1 on converting from denary to binary. Okay. We are going to see the second method. This is the first method. Okay. Now the second method, how we can do that. In the examination, you can choose either of one method in order to solve it, until unless it is mentioned that you are supposed to do both the methods. Okay, but most of the time, if you will see the papers, they never mention about both the methods. So you can choose any method which you think is easier for you to do it. What I recommend is that when you have a longer value, okay, always try to use the second method. Okay, now 72 is the number, and this is called as repeated division method. What it is called as repeated division method. As we have to convert into binary, so we are going to divide this number using 2. Okay, 2 3s are 6, carry 1. So 2 6 are 12. Nothing is left. So we are going to put the remainder on the right side. Okay, because no remainder is left, so we are going to put 0. 2. 2 ones are 2. 2 eights are 16. No remainder left, 0. 2 nines are 18. Nothing left, 0. 2 fours are 8. So this is 9. So 1 is left. So we are going to put it over here. 2 times 2 is 4. Nothing is left. 2 times 1 is 2. Nothing is left. Now, if you can see, we cannot divide 1 by 2. So what we will do, as per the rules of the division, we are going to put 0 over here and 1 will be your remainder. Okay? Because we have to represent binary using 8 bits at least. So if you can see over here, 1, 2, 3, 4, 5, 6, 7 bits. So in order to make 8 bits, we are going to do 2 divided by 0, remainder will be 0. Now it is going to be 8 bits. So we are going to start from bottom, we go up to top. From bottom to top, we will start writing the answer 0, 1, 0, 0, 1, 0, 0, 0. This is your answer. And if you can see it, we are getting the same value as we have the value through method 1. So whether you are going to use method 1 or 2, you will get the same result. I hope this is clear to everyone. If you have any problem, you can comment and you can ask me if you need any kind of help. And please share this knowledge with others, subscribe this channel and like it. Okay? Thank you very much. Allah Hafiz.